Let's take a look at 3 radical 8 minus radical 2. This isn't 3 radical 6 or anything like that. The fact that this is a radical 8 and this is a radical 2 means that they are not like radicals. We cannot subtract them. We can't subtract unless we have like radicals. But we're not just done here. Remember, last time we looked at simplifying radicals. We saw that because 8 has a perfect square factor, 8 is 4 times 2. That means that we can rewrite radical 8 as radical 4 times radical 2. Square root of 4 is 2. So 3 radical 8 is actually the same as 6 radical 2. Well, 6 radical 2 minus radical 2, that's something we absolutely can do. 6 of them minus 1 of them is 5 of them. So the answer is 5 radical 2. Now I'm saying 6 of them minus 1 of them equals 5 of them because I'm trying to make this as simple as possible to understand and to work through. But you have to keep in mind, in the context of where we are in the material, the last major thing we focused on before radicals was factoring. So let's take a look at this. This answer, this last step of 6 radical 2 minus radical 2. What's really going on here? To simplify, we can factor out a radical 2. And if we factor out a radical 2, what are we left with? Distributive property. Radical 2 times 6 is 6 radical 2. Radical 2 times negative 1 gives us minus radical 2. Working in the parentheses first, order of operations to simplify. 6 minus 1 is 5, and radical 2 times 5 is 5 radical 2. So what's actually happening is we're factoring to get to the answer. It turns out that when we've been combining like terms, we've been factoring all along. But now that we know factoring, we can call it out for what it is. When we use the distributive property in reverse to help us get to our answer, we're using factoring. But we have a simplified way of thinking about it. When it shows up like terms or like radicals, we get the same answer by talking it out. 6 of them minus 1 of them is 5 of them. Whew. Now that we talked through all that, Let's take a look at something like this. Radical 45 plus 3 radical 18 minus 8 radical 20. Now, I'm often asked for test tips. And this is a great example of a problem that can use my really only test tip. I can't tell you how many times I've heard over the years that I was ready for the test, but then I went to take the test and I forgot what I was doing. And there could be many reasons, many different ways of saying or explaining why everything was forgotten. But it boils down to that basic statement. I thought I was ready, but it turns out I wasn't for some reason or another. Which is why I have exactly one definition of being ready for the test. And that definition of being ready for the test is if you can go to any video lecture covering material that's on that test, come to a random point at the beginning of a problem like this one, stop the video, and without any notes or any assistance at all, if you can do the whole problem without watching it, using the same steps I did and getting the same answer I did, if you can do that, you're ready for the test. But if there's even one problem in these videos that if you come to the beginning and you can't get to the answer without any assistance, then you are not ready for the test. Simple as that. Any other method of determining, am I ready for the test, will not give you a correct answer. But if you can do everything in these videos, start to finish, without help, then you're ready for the test. Radical 45 plus 3 radical 18 minus 8 radical 20. What are we doing? Well, adding and subtracting we can't do unless we have like radicals. Here we have a radical 45, a radical 18, a radical 20. Those are not like radicals. So as it stands, we can't combine them. But we can try to simplify each of these. We can try to get like radicals. So we'll try to split up 45 as the product of two numbers that has a perfect square factor. We'll do the same for 18, and we'll do the same for 20. 45, that's 9 times 5. Let me use a red, and let me try to use a darker green. It's going to be time to replace some of these soon. 9 times 5 is 45. Why did we pick 9 times 5 instead of 15 times 3? 15 times 3 is useless. 15 times 3 doesn't have a perfect square factor, but 9 is a perfect square. 18 is 9 times 2. 9 is a perfect square factor, so we can use that. 3 times 6, that would be useless. 3 and 6, we can't take the square root of either. We want to pick something where we can take the square root of 1. 20. 10 times 2 would be useless. What is useful would be 4 times 5, because 4 is a perfect square factor. So what do we got? If we split these, radical 9 times radical 5 plus 3 times radical 9 times radical 2 minus 8 times radical 4 times radical 5. The ones we can take the square root of, we do. Square root of 9 is 3. 3 radical 5. Plus 3 times, again, square root of 9 is 3 times radical 2. Minus 8 radical 4 is 2, so times 2 times radical 5. Simplify in front. 3 radical 5 plus 9 radical 2 minus 16 radical 5. Radical 5. And now that we've simplified all the radicals, our problem is 3 radical 5 plus 9 radical 2 minus 16 radical 5. Now, we might not be able to combine all of them, but 3 radical 5 minus 16 radical 5. 3 of them minus 16 of them is negative 13 of these radical 5s plus 9 radical 2. And that's our answer. Simplifying this problem, adding and subtracting these radicals, the one and only correct answer, negative 13 radical 5 plus 9 radical 2, which can also be written as 9 radical 2 minus 13 radical 5, depending on the order that you picked to put your final answer in. This is the only answer, though, written one of these two ways. Anything else would not be completely simplified. Since these are the only two that ended up adding, a question you might have is, do we need it to be 9 radical 2? Since it can't change from the radical 18, since that doesn't play, could it be negative 13 radical 5 plus 3 radical 18? No, you cannot have a radical 18 in your final answer. It has to be simplified, like we learned in the last lecture. Radical 18 becomes 3 radical 2. So that whole term is going to be 9 radical 2. That would be like leaving an unsimplified fraction in your answer. Makes it wrong. Let's look at another like this. Eight radical 75. Oops, I'm off screen. 8 radical 75 minus radical 12 plus 2 radical 8. Simplify the radicals. So 8 radical something minus radical something plus 2 radical something. 75 is 25 times 3. 12 is 4 times 3. 8 is 4 times 2. 8 radical 25 radical 3 minus radical 4 radical 3 plus 2 radical 4 radical 2. Okay. 8 radical 25 is 5. Radical 3. Radical 4 is 2. Radical 3 plus 2 times radical 4 is 2. Radical 2. Oops. I accidentally put an equal sign there. That should be a minus. 8 times 5 makes that 40 radical 3. Minus 2 radical 3 plus 2 times 2 is 4 radical 2. 40 of the radical 3's minus 2 of the radical 3's gives us 38 radical 3 plus 4 radical 2. And that's the answer. So just to bring this back to what I said about being ready for the test. If before the test you come to this video, you come to this problem, and you pause it. If you can't work out to get 38 radical 3 plus 4 radical 2, understanding why you do every step in between, if you can't do that, then you're not ready for the test. Someone who pauses this and can get to the answer and understand why they did every step they did without me doing it with them, that's being ready for the test. Homework can help with your practice, but you should never, ever be prioritizing homework over understanding the lecture. Okay, so we've been doing just numbers so far. Let's take a look at x times radical 98x cubed y plus 5 radical 18x to the 5th y. These are not like radicals, so we can't add them, at least not like they are. So we attempt to simplify like we did so it's going to be x radical something plus 5 radical something. Perfect square factors are what we're looking for. 98, that's 49 times 2. X cubed, how did we simplify that last time? When we're looking for a square root, we want the highest power of 2 that we can fit in. So we call x cubed x squared times x. And then y we can't simplify. We can't break up any. So it's just y. Over here, 18. 18 is 9 times 2. X to the 5th, highest power of 2 that fits into 5 is x to the 4th. So we split that x to the 4th times x, and we can't simplify the y. What did I do next? Well, continuing under the radical, and with practice, you might be able to get to the point where you can do some of these steps in your head. That's good if you get there. But you have to understand why we're doing the things we're doing. I'm going to put the perfect squared factors in the front. So here, the 49 and the x squared, those are things we can take square roots of. And then the stuff we can't take the square roots of, that's the 2, the x, and the y. Here, things we can take the square root of are the 9 and the x to the 4th. The things we can't are the 2, the x, and the y. So if we split these up, we have the x, the square root of the 49x squared, and the square root of the 2xy. Plus we have the 5 times the square root of the 9x to the 4th times the square root of the 2x and the y. And since I'm running out of space here, we're going to continue down. Again, if you're taking notes and I'm presenting this to you vertically, please do not write things across. The point of how I'm showing it to you is that that is how you are supposed to show your work. If you're trying to squeeze it all onto a page, you're not helping yourself. Maybe that's how you've always taken notes. Maybe you're running low on paper. I do understand these reasons, but the point of this class is to train you to do math problems and how to show your work and to get you ready for future classes. If you're saying, hey, I'm seeing it this way in the video, but I'm going to write it down some other way, what are you doing? I mean, just really think about that. The act of writing it down is not what's going to help you. What's going to help you is being able to look back at it later. When you get to studying for the test and you come to a problem like this, being able to get to the final answer and understand what happened step by step. If you get stuck, you can then look back at how we did it. You wouldn't need the video for that. Hopefully you're taking notes that are full examples. You're expected to know all of this when you get to the next class. People who struggle in the next class, it's because they don't know how to do the work from this class. This is not a class you want to barely scrape by in. If you're moving on to the next math class in the sequence, this is something you need to know how to do. Anyway, to continue this problem, because we're not done with it yet, I'm going to move this up here, and then you'll keep writing it down underneath, we have this x square root 49x squared square root 2xy plus 5 radical 9x to the fourth radical 2xy. Let me move that. That angle was not helping. Radical 9x to the fourth radical 2xy. There we go. So what's our next step? Our next step is taking the square root of the one we actually can. So this is going to be x times 7x, because 7x times 7x is 49x squared, times, we can't simplify this one anymore, radical 2xy, plus 5 times 3x squared times 3x squared is 9x to the fourth, times radical 2xy. And then x times 7x is 7x squared. So we have 7x squared radical 2xy, plus 5 times 3x squared is 15x squared, times radical 2xy. Why did I point out that it's just factoring? Well, because even though you can get to the answer of 22x squared radical 2xy, using our 7x squared of these things plus 15x squared of these things method, it might be easier to just say, now hold on a second, I'm going to factor out the radical 2xy. And in fact, I'm going to factor it out and put it on the right side because I know that's where the radical is going to end up. And if I factor out the greatest common factor of the radical 2xy, and I've factored it out to here, what am I left with? What's the leftover piece? 7x squared plus 15x squared. 7x squared plus 15x squared is 22x squared. So 22x squared radical 2xy is the final answer. Now in this one, the 7x squared and the 15x squared were like terms, so we were able to combine them to get the answer. But if it turned out that we didn't have like terms, we would not have been able to simplify any further past that last step before the circle. So if we had 3 radical 5x plus 2x radical 5x, 3 of these plus 2x of these would be 3 plus 2x of these. We can't combine them anymore. You can think of it as taking that common factor and factoring it out to the right. Or if it helps you think of it off to the left, if this is too weird for you, then we're factoring out the radical 5x. What are we left with? 5x times 3 is 3 radical 5x. 5x times positive 2x is positive 2x times radical 5x. And then move this from being the first factor to it being the second factor. Switch the order of the two factors. Because when we write our final answer, we want the radicals at the end. So that's adding and subtracting radicals. We have to make them like radicals. So as we move into the next section, we're going to move from adding and subtracting the radicals to multiplying. And as kind of a refresher, the product property, the property that says if we're multiplying two radicals together, we can multiply underneath. That's what's always at play. So we can't simplify radical 6 and we can't simplify radical 10. But if we multiply them together underneath, we get radical 60. And 60, while 6 and 10 might not have been able to be simplified, 60 is 4 times 15. So radical 4 times radical 15 gives us an answer of 2 radical 15. Now remember, we have our special instruction that's always at play. Assume that we have positive real numbers. Here we can see 6 and 10 are positive real numbers. We don't have to worry about any absolute value signs. But our next example is going to involve x. So we do have our special instruction. X represents a positive real number. We don't have to worry about putting absolute value signs in. Let's do one more before we bring an x in. Let's do something in this form. 5 radical 3 times 2 radical 15. Just to point out that these are two simplified radicals being multiplied together. So we are allowed to multiply the numbers and then multiply the radicals. 5 times 2 is 10. And then radical 3 times radical 15 is radical 3 times 15. 3 times 15 is 45. We ask ourselves, can this be the final answer? No, because 45 can be simplified further. (45) is 9 times 5. So 10 times radical 3 times radical 5. Or sorry, 10. I got ahead of myself. 10 times radical 9 times radical 5 is 10 times 3 times radical 5 is 30 radical 5. So 30 radical 5 is the final answer there. Okay, now I'll do the one that involves the x. Multiply the stuff out front together first, and then just multiply your radicals. It's going to look scary. Don't be scared. So the reason I decided to put an extra step in there is because instead of a square root, we're going to have a cube root. 2 cube root of 3x times 4 cube root of 18x squared. Now, these are not like radicals. I apologize for using that term for these previously. What did I say these are called? These are radicals of the same index. They're both cube roots, but that means we can use our property because they're both cube roots. Two times 4 is 8. And then the cube root of this stuff times the cube root of this stuff is the cube root of this stuff times this stuff. So 2 times 4 is 8. And then the cube root of this times the cube root of that is the cube root of this times that. Can't do that with adding and subtracting, but multiplying, we can do that. So 8 times the cube root, 3 times 18 is 54. X times x squared, add the exponents, is x cubed. So pop quiz. Do we look for perfect square factors of 54, like 4, 9, 16, and 25 here? No. If it was a square root, that is exactly what we would do. But this is a cube root, which means we are looking for perfect cube factors. Like like 8, that's 2 cubed, or 27, that's 3 cubed. 54 happens to be 27 times 2. 27 is a perfect cube factor. X cubed is also a perfect cube factor. So we have 8 times the cube root of 27x cubed times 2. That's going to be, we'll keep going down. That's going to be 8 times the cube root of 27x cubed times the cube root of 2. That's 8 times 3x times the cube root of 2, which is 24x times the cube root of 2. Which is the answer. Why is the cube root of 27x cubed 3x? Because the cube root of 27 is 3 and the cube root of x cubed is x. So hopefully you are seeing why it is important to understand every lecture before moving on to the next. There was a lot of stuff with radicals in the last one. If you didn't understand it then, now you have to understand it in addition to the new material, because the last section is now a part of the sub-steps of this section. And now everything about adding, subtracting, and multiplying radicals you need to know, because if we ever see radicals moving forward, and we will, not just in this class, but also the next class, next course, next math course past this, you're expected to know how to do all this. If not, that becomes really difficult, because this is the time to learn this. Next lecture is the time to learn something else that requires you to know how to do this. You might only need a C to move on to the next course, but being completely honest with you, you want as close to perfect knowledge of this stuff as possible, or the next class is going to be very, very, very difficult. Okay, let's make the multiplication more advanced now. Let's say we have 3 radical 11 times radical 11 plus 2. Well, we can't add together radical 11 plus 2. They are not like radicals, so we can't add them. And there's no way to simplify them to be able to combine them in any way. But what do we do if we had 2 times x plus y? We can't add x plus y, but we need to get rid of the parentheses. How do we do that? We distribute. So it would become 2x plus 2y. It's the same thing we do here. But we need to be careful, because something happens, could be described as magical, when we multiply a radical times a radical, and especially when it's the same. Let's not do too much in one step. 3 radical 11 times radical 3 radical 11 times radical 11 is 3 radical 11 times radical 11. Not actually doing it yet. And then 3 radical 11 times positive 2 is going to be positive 3 radical 11 times 2. Just so you can see. Radical 11 times radical 11 is the same as radical 11 squared. So the square and the square root cancel each other out and just leave us with 11. So radical 11 times radical 11, a radical times itself just leaves us with what's underneath. Plus 3 radical 11 times 2 is 6 radical 11. 3 times 11 is 33. 33 plus 6 radical 11 is our answer. So that's how we use the distributive property when radicals are involved. Let's do another. Five radical x times 2 radical x minus 3 radical y. We have our special instruction at play. Assume all variables, so assume x and y, represent positive real numbers. We don't have to worry about any absolute value signs or anything like that. We distribute. 5 times 2 is 10. Radical x times radical x. I'll leave that unwritten out for now. 5 times negative 3 is negative 15. Radical x times radical y. I'll leave that undone for now. A radical times itself is just what's underneath. Radical x times radical x is just x. Minus 15 radical x times radical y is radical xy. That's the answer. 10x minus 15 radical xy. Let's keep going. Let's take a look at multiplying two radical expressions together that resemble binomials, so 2 terms each. Radical 5 plus 3 radical 2. And we're going to multiply this times 2 radical 5 minus radical 2. If this was something like x plus 3 times x minus 4, what would we do? We would FOIL. First, x times x is x squared. Outer x times negative 4 is negative 4x. Inner positive 3 times x, positive 3x. Last, positive 3 times negative 4, negative 12. Then we'd combine like terms. Minus 4x plus 3x. That's negative x. Minus 12. But first, outer, inner, last. FOIL. It's just double distribution, but FOIL is how people remember this. The first terms, the outer terms, the inner terms, and the last terms, and you're careful. You're careful to use the signs in front and keep track of your signs. First, that's radical 5 times 2 radical 5. Outer That's radical 5 times negative radical 2. Positive times negative is negative radical 5 times radical 2. Inner. Positive times positive is positive. 3 radical 2 times 2 radical 5. So I'm not actually doing any of it yet. I'm just setting up first, outer, inner, last. Positive times negative is negative 3 radical 2 times radical 2. So notice when it was radical times radical, I can just put them right next to each other. But if the radical was ever multiplied by something with a number, I have to indicate that there's some separation. So one way of showing separation is using the multiplication dot. Another way of showing separation is by putting each piece of the multiplication in parentheses. So let's start simplifying. Now, if you can grasp how to do each of these pieces, then you don't have to write this step out. When you're doing your FOIL, you can go first, radical 5 times 2 radical 5 is 2 times 5 is 10. Or once it's all written out, we can just look piece by piece by piece by piece. All we have is the 2, and then radical 5 times radical 5. Multiplying a radical by itself leaves us with what's underneath. 2 times 5 would be 10. Minus radical 5 times radical 2 would be radical 5 times 2, which would be radical 10. And we can't simplify radical 10 at all. Plus 3 times 2 is 6. Radical 2 times radical 5 would be radical 2 times 5. So plus 6 radical 10. Minus 3, and then radical 2 times radical 2 is just 2, because a radical times itself just leaves us with what's underneath the radical. So minus 3 times 2 is minus 6. Finishing up simplifying, 10 minus 6, positive 10, negative 6. 10 minus 6 is positive 4. And then negative 1 of these radical 10s plus 6 radical 10s would be negative 1 plus 6 of the radical 10s, which would be positive 5 of the radical 10s plus 5 radical 10. So 4 plus 5 radical 10 is the answer. Under no circumstances are you to make this 9 radical 10. If you see this 4 plus 5 and you think that means that you need to make it a 9, you deserve no credit on the entire problem. Honestly, if you got through every bit of it and then came to the end and said 4 plus 5 is 9, so 9 radical 10, you would get no credit and you would deserve no credit. Because even though you went through all of this, and by the way, the only new thing is what do we do when we multiply a radical times a radical? Everything else here we did back in the section where we multiplied polynomials. But then if you come to here, 4 plus 5 times radical 10, and you violate order of operations, which says you multiply before you add, therefore this is a thing that is kept together because multiplication comes first. You cannot add 4 to this and end up with 9 radical 10s. You cannot combine these. They are not like radicals, so you cannot add them together. If it was 4 radical 10 plus 5 radical 10, then you'd have 9 radical 10. But 4 plus 5 does not become 9 in this instance. You cannot separate the 5 from the radical 10 because multiplication comes first. So this is joined together. And we know how to add radicals now. Let's look at another. Three radical x plus 5 radical y times 2 radical x minus 7 radical y. Again, let's FOIL. First, 3 radical x times 2 radical x. Outer, positive times negative is negative, so minus 3 radical x times 7 radical y. Inner, positive times positive is positive, so plus 5 radical y times 2 radical x. And then last, if you have more room off to the right of your page, please write it next to, but I'm going to put it here. Positive times negative is minus 3 radical x oops, sorry. Not the 3 radical x. First, outer, inner. We're doing last. Positive times negative is negative. 5 radical y times 7 radical y. Okay. 3 times 2 is 6. Radical x times radical x is x. Minus 3 times 7 is 21. Radical x times radical y is radical xy. Plus 5 times 2 is 10. Radical y times radical x, that's still radical xy. And then minus 5 times 7 is 35. Radical y times radical y is just y, because a radical times itself is what we're left with underneath. Negative 21 of these radical xy's plus 10 of these radical xy's, those are like radicals, so just like terms, we combine. We end up with 6x. Negative 21 of these plus 10 of these is negative 11 of these radical xy's minus 35y. And that's the answer. 6x minus 11 radical xy minus 35y.